Hello, we are starting another lesson. We are in section 5.4, title Analyzing the Graphs of Polynomial Functions. It's kind of what we did in the last video, but that was focused on end behavior. Today we're going to look at what I would call sort of the middle behavior. Now, oh, and by the way, I am joined with my dog again. I don't know if he'll speak up like he did in the last video. We'll just have to see. But just know that he's a good boy. All right. So I will be explaining a lot on the first couple of exercises, so please listen close. They'll be doing most of the teaching, and then after that, they're pretty repetitive. It's just seeing the same thing over and over to make sure you get it. And this will be one of those lessons where after the first couple of examples, if you feel like you get it, you can probably stop the video and get straight to work. You can always come back to the video if there's something that looks complicated or confusing. So even though there's a lot to explain and a lot to know here, the work will almost entirely be done on Desmos. So you do want to have the graphing calculator. It's the same thing we've been using all year. So I'm going to bring that up over here. Well, I'll make it a little smaller and get rid of that. Okay. So look at these directions. So in each problem, we're given a polynomial. It says, state the maximum number of turns the graph of each function could make, then sketch the graph, state the number of real zeros, approximate each zero to the nearest tenth, approximate the relative minima and maxima to the nearest tenth. Wow. Now I could go up here and write out all those terms as vocabulary and define them and everything, but I think as I go through the examples, even after just 2 or 3, you'll get it. I think you'll get it. It should be okay. So what I've done is I've set up all of my answers so that I can write them out and hopefully fit them in fairly easily. If you're going to do this on paper, kind of do what I'm doing. If you're doing this on your iPad, if you take the scissors, circle what I wrote here, hit duplicate, and you can just slide this over. Oops, well, darn it. That was a mistake. Here, let me do that again. Slide it over, and there we go. And then you've got the same thing to work with as I do. You can make it smaller so you have more room to write, or whatever you need to do. But, okay. So, state the maximum number of turns. We talked about this a little bit yesterday when I did end behavior. So, in general, a third degree polynomial with an even or the positive lead coefficient has this kind of shape right here, that spaghetti shape. But it could also have this shape. So either one of those are possible. The second variety does turn. It goes up to down, and then it goes from down to back up. Let me try to be a little more clear as I do that. So it goes up, and then down, and then up, whereas this one just keeps going up. So there's a maximum on this of 2 turns. Now, how are you supposed to know that? I'm not going to tell you yet. I'm going to do another example and then see if you can figure out how that happens. I will tell you in a few minutes. Don't worry. Now, the number of zeros, the zeros themselves, the minimum and the maximum, you're going to have to get by graphing on Desmos. So that's what I'm going to do next. So f of x, or you just do y equals x raised to the third power minus 4x squared plus 7. And here we go. Now you do see that this graph does indeed have 2 turns. It didn't necessarily have to, but this one does. It has a maximum of 2 turns. Now, how many zeros does it have? Zeros are the same thing as x-intercepts. So let me actually write that up here. Zeros on this worksheet are going to be the same thing as x-intercepts. And this one has 3. 1, 2, 3. If you tap them on your Desmos screen, it actually tells you what they are. So there are 3 zeros. What are the zeros? And this says round to the nearest tenth. So this says negative 1.164. If we round off to the nearest tenth, that's negative 1.1. I'm sorry, that's negative 1.2. I'm going to put a comma, and the next zero is 1.773. That's approximately 1.8. I'll put a comma, and then the third zero is 3.391. We'll round off to 3.4. So how many zeros are there? There are 3 of them. what are the actual values, you have to tap the screen and then round off those numbers to get them exactly. Now, minima and maxima, those are I cannot speak. Those are weird words. Maxima, though, this is like a Nissan. Anyway, that's plural. Minimum and maximum, you're used to seeing those words. It's like highest and lowest, right? Minima and maxima is like in Latin, I think, how they make things plural. Whatever. If you look at this graph, what I'm tapping right there is a minimum value. So it is a point which is 2.667 comma negative 2.481. The minimum value is technically the y value. I need to check the answers and see whether they want us to put both or, where am I? Yeah, both coordinates down. So the minimum or minima here is the point 2.7 comma negative 2.5. And I know Desmos rounds off to 3 decimal places. The worksheet is asking you to round off to the nearest tenth, which is 1 decimal place. So that's why I did that. Now, is there a maximum point on this graph? Yeah, right there, 0.7. So just 0.7. And that's it. That's how we're going to do all of these. Well, no, now I have to graph it. So I'm going to approximate where these points are. I cannot get exactly, obviously, because they're decimals. So 3 point something. The y-intercept can be helpful in getting a reasonable graph. The minimum here, 2.6, negative 2.5-ish, right around here. And so you just do your best to sketch what we can. Now, if I was combining yesterday's lesson, I would also talk about how this arrow goes down to the left and up to the right. So we could do that other notation, you know, the f of x infinity, negative infinity stuff. We don't have to, so I'm not going to bog you down with that right now. We're just focusing on what we call what I call the middle behavior. So how does it curve? Where does it touch the intercepts? Are there any of these maximum points or minimum points? And that's what that right here is, and we would call that an analysis. We've analyzed the graph. It's sort of a visual analysis with the help of a graphing calculator. Like I said, I'm going to talk a lot about the first couple, but once you get it down, it should be fairly easy to do. All right, let's do number 4. Now, number 4 is positive, even, so I know that from yesterday it's going to be this shape, a parabola, which means it can only have one turn. It goes down and then it turns up. Now, yesterday we did do some examples with a 4th power, and I talked about how that could be sort of a W shape. I don't know if you remember that. If you didn't watch yesterday's video, maybe you should. Anyway, a 4th power could create a W which has 1, 2, 3 turns to it. And it turns out the maximum number of turns is always 1 less than the degree. So a 2nd degree has a maximum of 1 turn. A 3rd degree has a maximum of 2 turns. So that is the secret for answering that maximum number of turns question. All right, let me go ahead and graph this so we can finish this exercise. Y equals, f of x equals, y equals, same thing, 2x squared plus 2. So what do we have here? The number of zeros. Remember, zeros are x-intercepts. Where does this parabola cross the x-axis? And the answer is it doesn't. So the number of zeros is simply 0. There are none. So for the next line, what are they? Not applicable. If there are none, we can't tell what they are. Minima, is there a minimum value here? Yeah, the vertex of that parabola is the point 0,2. That's the lowest point. That's called the minimum. Maximum, well, no, those all go up to infinity. There are no sort of humps or hills or whatever you want to call them. So that's, I guess, another NA. And then to sketch the graph, you just put the vertex and draw the U shape. And that should be good. Did I ever check number 2? I don't know. Let's check this one. So, okay, I used NA for these answers. They wrote none, but yeah, this answer looks great, just like my answer. And then do we want to check this one? I'm not going to remember all those numbers in my short-term memory as I scroll down here. But yeah, I think that all looks, I think we got all those. Looks good. Okay, so if you got this, you can stop the video and go ahead and get to work. If you feel like you need extra examples, or if you want to see some with higher powers like 4th power and 5th power, then, you know, keep watching or skip ahead or whatever you need to do. So here goes. Number 6, maximum number turns is going to be 1 less than the highest power. So if that's a 3, there are 2. The number of zeros, I need to graph this. So y equals negative x raised to the 3rd plus x to the 2nd plus 3. There is 1 0. It crosses the x-axis 1 time. Where does it cross the x-axis? At approximately 1.9. Again, remember, I'm rounding that off. Minima and maxima. This is going to be a little tricky, but they are there. The minimum seems to be 0, 3, and the maximum is, wow, 0.7, 3.1. Now, if I want to sketch this, so I got to put a dot right about there, a dot there, another dot right about there, and we go like this, and you see there's a turn and another turn, and hopefully when I check number 6, that is going to look pretty good. And I think hopefully that's all right. I'm just using my short term, and like trying to remember that's 1.9 and all those decimals, 0.7, 3.1. That's not easy. But I don't want to scroll up and down over and over again and make you dizzy. So, all right, number 8. Now, could you graph this first? Yeah, you could, but still, the number of turns you don't necessarily, the graph won't necessarily tell you. There's a maximum number of 4 turns, 1 less than this. But the graph itself could have 3 turns or 2 turns or 1 turn or no turn at all. So, all right, y equals x raised to the 5th minus 3x to the 3rd plus 1. Oh, look at that. Okay, maximum, I'm sorry, the number of zeros, there appears to be 3 zeros. Oops, can't write with the eraser. There we go, 3 zeros. What are they? The first one is negative 1.8. And hopefully you're good with the rules of rounding. You know, 1.78 rounds up, right? The next one is 0.7. And the next one is 1.7. Minimum, there is a minimum value. It's 1.3 comma negative 1.9. And the maximum is right up, sorry, right up there. Got a little clumsy with the screen. Negative 1.3 and 3.9. And now we need to try to sketch this son of a gun. So put a dot here, put a dot here, put a dot right about there. A maximum, somewhere around here. We got the y-intercept right there. Now that y-intercept, by the way, let me talk about that. That 0, 1 is not one of the answers here that we're supposed to write down. I'm just checking it because it's going to help me make a better graph when I go to sketch it over here. So there's just certain points that, you know, they help if you can sketch them in. All right, so like that minimum is another point that helps you sketch in the graph. So with all these points sketched in, now I can sort of hopefully draw a better, yeah, this I kind of messed up like that was how it's supposed to look. In fact, I gotta, oops, that's not the eraser. There we go. Now, is mine perfect? No. Do I expect yours to be perfect? Yes. No. Good enough, you know. The numerical parts of your answers, they need to be perfect. I mean, that's black and white. Either you get them right or you don't. The graph, I mean, look how sloppy mine is right there, and I screwed up that curve a little bit, but it's good enough, right? So when you go to check yourself, don't be super brutal on yourself unless that's how you want to grade yourself. I mean, if you want to be really strict, so be it. Okay, number 10. So fourth power means there's a maximum of 3 turns. Let's actually graph it and see what happens. Y equals negative x raised to the fourth plus 4x to the second minus 2x minus 2. And we do have 3 turns. It goes up, well done. It goes up, it turns and goes down, it turns and goes up, it turns and goes down. Number of zeros. I only see 2 zeros. The first one is negative 2.1, and the second one is negative 0.5. Is there a minimum value here? Yep, it's that point right there. So it's, what is that, 0.3 comma negative 2.3, rounding off. Maximum, there's actually 2 maximum values. You know, I got too many things. There we go. There's 2 of them. So that one first up there at the top is negative 1.5 comma negative, nope, that's positive 4.9. And then the second maximum right there is 1.3 comma negative 0.7. And now I need to try to sketch this. This is going to take some work. So put a dot here, put a dot right about there. In between them, 1.5 comma 5, 4.9 right up there. That y-intercept might be helpful. Right next to it is a minimum. Then up here we have a maximum. And then it sort of turns down, goes like this, up through there, hits a maximum, turns down. So you see things like the zeros or intercepts, the maximums, the minimums. Again, those are all analyses of the middle behavior of the graph as opposed to the end behavior, which we did, in the last lesson. Why did I do that? I'm trying to erase. All right. If you're, I haven't been checking myself. Gosh darn it. All right, number 10. And it's a lot to remember. So 3, 2, negative 2.1, negative 0.5. Yep. And then 0.3, negative 2.3. 0.3, negative 2.3. Yep. 1.5, 4.9. Yep. 1.3, negative 0.7. Yep. All right. Why, checking these is just a pain. But the good news is there's only one left. All right, maximum number of turns. Third power, 2 turns. Number of zeros. Well, got to graph it to see. Y equals x raised to the third plus 5x to the second. Oops, all right, that's all messed up. There we go. 5x to the second plus 3x minus 4. Did I type it in correctly? Okay. How many zeros are there? Looks like there are 3. 1, 2, 3. What are the actual values of the zeros? One of them is negative 4. Another one is negative 1.6. And the third one is 0.6. Is there a minimum value? Yes. Negative 0.3 comma negative 4.5. And is there a maximum value? Yes, right there. Negative 3, 5. All right, let's try to get a graph going here. Negative 4 is a 0 or an intercept. Negative 1.6, which I'll estimate right there. Positive 0.6 right about there. A maximum at negative 3, 5 is up here. A minimum at, what was that? Negative 0.3, negative 4.5-ish right there. And that's the intercept, the y-intercept. So if I sketch sort of a spaghetti shape through all these points, that should be my answer. Well, mine looks really bad, but again, don't be real brutal. Whoa. Oh, that's number 10. Okay, number 12. There we go. I was about to say, wow, I've really got that wrong. I think those all work out to be right. Yep, looks good. Okay, so if you hung in this long, good for you. Hopefully you find this easy. You can get it all done. Give me a shout if you have any questions. I'll do my best to help you. Otherwise, I will talk to you